Hey everybody, JMac here from RouterDogs.com. Today we're going to talk about frame relay. Now, I get a lot of questions on frame relay, and it seems to be a tougher topic for people to understand. And it's because there's so many different types of encapsulation that people don't understand kind of how it all fits together. So let's take a look at it. Alright, I like to look at it as when you go outside, the last thing you put on is your jacket. And it's kind of the same way with encapsulation. Depending on what's the router's connected to at the interface is how it's going to put that layer 2 encapsulation on before it sends it out across the wire. So if you're connected to Ethernet, your frame is going to look like this. If you're doing HDLC or PPP for a point-to-point connection like a T1, your frame is going to be formatted like this. But if you're going through frame relay through a provider's network, your frame is going to be formatted differently. So again, I like to look at it as it's just 3 different ways to bundle up for the outside. If I'm going to the club, I'm going to wear something snazzy. If there's going to be a lot of wind or something, I'm going to wear a motorcycle jacket. If it's going to be cold, I'm going to wear my super pimpin' style jacket. So that's really what the layer 2 encapsulation is. It's just what's that last piece of encapsulation you're going to put on the packet before you send it out. And again, it's all based on what the router connects to. When a router first gets a packet, the first thing it does is strips off the layer 2, then it looks at the layer 3 to make sure it has the destination IP or has a route to the destination IP, and then once it does, then it looks at its outgoing interface and says, okay, what kind of encapsulation am I going to put on this before I send it out? Am I connected to Ethernet? Is it a HDLC encapsulation, or is it frame relay encapsulation? So hopefully that kind of clears it up and kind of puts these pieces here all together for you. Alright, back in the old days when dinosaurs ruled the earth, we did circuit switching. Think back to the Andy Griffith Show, where every time they would ring the phone, they'd get the operator and she'd have to plug one circuit out and plug it into another one to kind of give you that straight connection. And that's kind of how it works. So in order to have 3 remote offices in this case, I would have to have a router with 3 different WIC cards, or at least 3 different ports, and each port would connect to one individual place. And then so I had 3 circuits going through the provider's network. And these were specific circuits so that if a piece of copper somewhere broke and it was on my circuit, then my circuit went down. Even though there are other ways to get through the provider's network to get from point A to point B, if my circuit broke, my circuit was down. So it wasn't very user-friendly, and we've all had problems with T1 staying up. So the biggest problem with circuit switching was, one, a lot of configuration. Again, I had to configure all 3 interfaces. It was expensive, typically involved more equipment. I had to buy more WIC cards for something like this. And it wasn't very reliable. If any piece of copper went down somewhere, your stuff was out. So fast forward to the future. And here's what we're doing now. We're doing packet switching. Now, typically in the US, we're doing more MPLS. But in other countries around the world, frame relay is still very huge. So basically what we do is we get one line into the central office of our service provider. And then we pay just to route through the service provider, not one specific path, but just through the provider's network any way possible, preferably the fastest way possible. So that's what we do. We get one line from our router into the service provider, and then the service provider handles our exit points. So depending on how you have this set up, you may only have one card that you have to install and one configuration on that card to go out to your 3 different interfaces. And again, if something happens inside the provider's network, they reroute you another way in their network to get you to where you're going to go. So theoretically, less equipment, less configuration, more reliability. So that's kind of what was the big thing about frame relay. Alright, and when we talk about your provider's network, we're talking about something like this. This is your company, and there's your router, and then you go through your local loop to the central office, and then they connect to other central offices all throughout their network, and then finally somewhere out here there's an exit point that goes out to your remote office, wherever it may be, whether it's 6 miles down the road or something like that. So again, with circuit switch, you pay for a private circuit through their network, and if that circuit breaks, your line is down. But with frame relay and MPLS, if a piece of copper breaks, they just kind of reroute you around. Alright, let's talk about some basics of frame relay. Frame relay uses virtual circuits through the provider's network. So in other words, the provider says, oh, you go to the provider and say, hey, I need a circuit from this, from my location here to a location, 20 miles down the road to my new remote office. they look at their network and say, okay, you're closest to this central office and the endpoint is closest to this central office. So then they create their own virtual circuit from central office 1 down to central office 5 or whatever it may be. So a PVC is a permanent virtual circuit and a SVC is a switched virtual circuit. So for example, your headquarters may always need to connect to the remote offices because the remote offices may always need to get their email and their internet and everything through the headquarters office. But the remote offices may not need to talk to each other. So let's look at it as healthcare. You got 4 very small private practice doctor's offices, and then you've got your main headquarters office where everything's stored. Those remote offices may not need to communicate, but every once in a while they may. So you would pay for maybe a switched virtual circuit or something, some kind of availability so that these remote offices could talk to each other if they ever need to. So again, PVC is a permanent circuit, you're sending a lot of traffic through there. And then an SVC is a switched virtual circuit, which is a temporary circuit, not used very much, only comes on when they need it. All right. Next term is the CIR, which is your committed information rate. Now, this is the rate that you negotiate with your service provider for how much bandwidth you're going to get on each permanent virtual circuit or PVC. Now, the beauty of frame relay is typically your providers, if users are not using all of their bandwidth, they'll allow other users to go above their committed information rate. And they refer to this as the committed burst information rate, or the CBIR. So whenever you're setting up bandwidth, if you've negotiated CBIR, you also want to take that into account when you're setting that up. And let me kind of show you a little. Alright, don't laugh too much about this. But anyway, you've got your headquarters office, and then you connect to a central office over here, and then they have their exit central offices that connect to remote office 1 and remote office 2. So you get a 64 kilobyte line from headquarters to your closest central office. And then what you have to do is negotiate the speed to the 2 remote offices. So on the blue circuit, this blue PVC here, we've negotiated a CIR of 32 kilobytes per second with a burst rate of 16 megabits per second, 16 kilobytes per second, for a total speed of 48 kilobits per second. So on this PVC here, I would set a bandwidth setting of probably 48. But over here on the right, where the central office that doesn't need a whole lot of bandwidth, I've just negotiated a CIR rate of 16 kilobytes per second, and there is no CBIR. So again, you can see if I'm bursting over here and doing the whole 48, it only leaves me another 16 to get to my total of 64. So when you're doing these links here, in this case, I would probably use, I've only got one line coming out, so I'd probably do sub-interfaces. One sub-interface I'm going to set for 48, and one sub-interface I'm going to set for 16. So that's where the CIR comes into play. Now, don't forget, when you set the bandwidth setting on the interfaces, that does not change your actual bandwidth. It's just a number that's used for route calculation by routing protocols like EIGRP and OSPF. So just because I set this line here, this virtual circuit, at 48 kilobytes per second, it doesn't limit me to 48 kilobytes per second. It just says when the headquarters router calculates a route from headquarters to remote office 1, it's going to assume 48 kilobits per second as the number to calculate the route there in the routing metric, depending on what you're using, OSPF, EIGRP. So don't let that confuse you. Just because you have a CIR of 32 and a burst rate of 16 and a total rate of 48, blah blah, and you set that rate at 48, that doesn't mean you can't go above 48 or you can't go below 48. It doesn't affect your actual bandwidth at all. It's only used for routing calculations, but you want your calculations to be as accurate as possible, so you would set it like that. Alright, so hopefully that makes sense about the CIR. Alright, next, with frame relay, your provider comes up with DLCIs, or Data Link Connection Identifiers. And what they are is your provider says, okay, if you're coming to this central office from your connection, we're going to assign that a DLCI number of 103. And then when you exit out central office 5, we're going to assign that number 301. And again, in Cisco, especially with the documentation, they just like to reverse the DLCI so you can keep them straight. So if it's 103 on one end, it goes in reverse, 301 on the other end. Now, the DLCs are locally significant. Well, what does that mean? it means for you, your router is going to have a bunch of different DLCIs. But for your service provider, they may have a boatload of DLCI. So something like this. Here's your provider's network. So here's Time Warner Cable or something like that. Now, they have a company that calls them and says, hey, we have a headquarters in Cleveland and we need to go out some office in Chicago. So they'll say, okay, hey, your entrance point from the Cleveland central office is going to be DLC 103, and your exit point from the Chicago office is going to be 301. And they provide those DLCIs to you. So for you, those are important, and your router is only going to have one 103. Your router is only going to have one 301, stuff like that. So they're locally significant to you, but for your provider, it doesn't matter, because all they do is they say anything coming into the central office here from Cleveland from this line is going to be 103. But they can also have 103 in New York, so they can have multiple instances of DLCIs. So don't let that confuse you. As far as the service provider goes, it's all mapping he does inside his network, and then he gives you those DLCI numbers, if that makes sense. So just to recap, for you, the DLCI numbers will all be unique, but for a provider, they may have the same DLCI number inside their network because they just map them differently. Alright, so once you've negotiated your CIR, then your provider gives you your DLCI numbers. At that point, all you have to do is map the destination networks to the DLCIs. And then for the DLCIs, 1 through 15 and 108 through 1023 are reserved, so they typically give you a number between 16 and 1007 as your DLCI. Alright, there's also an LMI associated with Frame Relay, and that is the Link Management Interface. Now, the easiest way to explain it is, it's kind of like a keep alive between you and the central office that you're connected to. So every 10 seconds or so, the LMI sends some kind of keep alive signal to the Frame Relay switch at your provider to say, hey, I'm still here, hey, I'm still here. But it also works to get the status messages of the line. What's going on, how many error message, a bunch of other communication. So I'll show you a command when I'm done here, how do you access the LMI, and you can actually see all those status messages and kind of keep an eye on your Frame Relay. So that's the two big important pieces, your DLCIs and your LMI. Alright, now with Frame Relay you have to decide how you're going to set it up. You can either use sub-interfaces for one headquarters router to connect to everybody else. So you can have one physical interface connect to 3 DLCIs through the cloud, or you can do separate interfaces. We'll talk about both of those in just a second. Alright, if I'm doing one interface per Frame Relay or per DLCI, it's pretty easy to set up. I just go to the interface, serial 000, I assign the IP address, I change my encapsulation to Frame Relay, and then if I have a hub and spoke, I may turn off inverse ARP. Then I map the DLCI to the destination network, and then I turn the interface on, and that's it. So it's not very complicated. And you have to do this for every interface. Now, each DLCI is handled kind of like its own virtual kind of connection. So each end has to be a part of the same network or subnet. So here's what a single connection would look like. You've got your headquarters router and he goes out to remote office 1 or remote office 2. So when he connects, he's got a physical 000 here and a physical 001 over here. So these 2 points here have to be on the same subnet. And then your provider handles everything in the middle. So again, right here where the little Z is, that's where your provider would be. So these 2 ends have to be in the same subnet, and then these 2 ends have to be in the same subnet. Alright, might make it easier if I actually show you the configuration. So now we're going to set this up. Alright, so here's what it would look like. I've got my headquarters office up here, and then he's going to connect to the central office or the ISP here. And then I got my 2 remote offices, remote office 1, remote office 2. Now at headquarters, their regular LAN network is 172.16.60.0 with a /22. And then his 2 interfaces, he's going to connect to remote office 1 on serial 000, 192.168.1.253 with a /30, and his DLCI has been assigned from the provider at 103, and then serial 001, and he goes to 249/30, and his DLC is 103. So 102 is going to connect down here to remote office 1, and his DLC is going to be 201, and then this guy is 301. So again, 103, 301 in reverse. But again, they also need to be in the same network. So 192.168.1.253, 192.168.1.254. So the remote office 1, he has an internal network of 10.110, and remote office 2 has a remote network of 10.220. So that's what we're going to set up. So headquarters is going to have two serial interfaces. They're going to go into the cloud, and then the cloud's going to split those out between remote office 1 and remote office 2. Alright, so starting with headquarters, here's what I would do. Go into the headquarters router. I'm going to turn it off. I'm going to put in a WIC 2T, turn that one on. Remote office 1, turn it off. He's going to get a WIC 1T. And remote office 2, off. WIC 1T, turn them back on. Alright, then from the headquarters router, ooh, that looks really small. Let's see if we can change this up a hair. Alright, that's a little bigger. Hopefully you'll be able to see that. And I'm trying to move it somewhere you can kind of still see the network. Alright, so I don't want to go into the setup. And don't be mad at me, but I'm not going to put a basic config on this router. Alright, so first thing I want to do is I go into the interface, so I'm going to go to serial 000. Helps if I spell it right. No skip step. Alright, once I go into the interface, I want to assign an IP address. So IP. Alright, and this is the first one, so it's going to be 253. And assign the IP address. Alright, next thing I want to do is I want to assign the encapsulation. So just encapsulation frame relay. And again, that says, hey, anything exiting this interface is going to be encapsulated with frame relay, or have the heavy winter coat jacket, or however you want to say it. Alright, once you do that, you want to do your bandwidth. Again, I'm just going to do 64. We're not going to play with CRIs right now. And then, now, all you have to do is map the destination network to the DLCI. In this case, my DLCI is 102. So for me, when I exit to 102, I'm headed for this IP address down here. So it's just frame relay, map, IP, then the destination network, 192.168.1.254. Space, and then the DLCI number. In this case, I'm headed out 102. So it's your local DLCI number, and it's his destination IP address. Now, at this point, if you're doing OSPF, you'd also put the word broadcast after this. But we're not going to be doing OSPF. I'll just throw in just to mention that if you're going to do some kind of routing on your network between all this stuff and you're using OSPF, you want to put this word broadcast. So I'll just throw it on there. Now, I also want to bring up the interface, and that one's up. Alright, now I can go to serial 001. Alright, same thing, IP address. Alright, encapsulation, frame relay, my bandwidth, and again I'm just doing 64. In the labs you can just do 64, but in the real world obviously you got to look at your CIR. Alright, once that's done, then your frame relay map, frame relay map. Now this guy's going to be mapping to remote office 2, so IP, he's mapping to 250. And he's mapping that on his locally significant 103. And again, if I was doing OSPF, I put the word broadcast after it. Alright, again, no shutdown. Alright, hopefully that works so that we can just go to our cables. And I'm going to grab serial cables. Alright, serial 0, because we go into serial 0. And 1. It's going to go into serial 1. So again, I've got my two interfaces, and they connect with two lines. Now, something I didn't show you if you're doing this in Packet Tracer, for this cloud, I just went here to WAN emulation down the bottom. It's the first cloud. Don't go to multi-user connection. Don't be that guy. WAN emulation, and I picked the very first cloud. And that's all that's here, and that's all I've done so far. So if you missed that step, I'm sorry because I didn't cover it, that's all you want to do. Go to WAN emulation, grab the first cloud, and put that there. Alright, let's see if we can get Remote Office 1 up. So I'll go to Remote Office 1. Same thing, CLI. No. Alright, he only has one serial interface. His IP address. Don't tell anybody I did that. I can't type worth a. Alright, after IP address, encapsulation, frame relay, bandwidth 64, and then now he wants a map. So frame relay, map, IP. Now again, he's mapping to my IP address, and he maps to 192.168.1.253, and his local DLCI is to 102. And again, if I put broadcast, I'm all covered, and that way I can put in OSPF later on, and no shutdown. Now, hopefully everything's set up now, so I go here, grab a cable, 001, and he goes to remote off. Now, I got all green lights, so that's good. So now I'm going to show you how to set up the frame relay cloud to emulate your provider. Alright, don't laugh if I screw this up. So I'll go to my cloud. Now first you need to go to each interface and assign the DLCIs for the provider. So remember 0 was my first one, so that was DLC 102. And I'm going to call this headquarters to remote 1 and an add. And then there was DLC 3 headquarters. I'm just going to do headquarters to R2 add. Let me get rid of that. Alright, that looks better. Headquarters R1, headquarters to R2. And I did that all on, you know what? I'm sorry, let me get rid of that. Remember, I'm only doing one interface, so the first interface, 102, went to serial 0. Serial 1 was 103, and that was headquarters to R2. Add. 2 was DLC 201, and that was R1 to headquarters. And add. Now, remember we talked about LMI. There's a couple choices you have for LMI. Cisco, obviously, we have all Cisco, so we can do all Cisco in the LMI. So by default, the LMI type is Cisco. But there's ANSI and there's Q933A. Now ANSI was assigned by T1.617 Annex D. And then the other one, Q933, was an ITU standard Annex A. Hopefully you're not going to use those. You're just doing this on Cisco, and since this is a CCNA class, you're going to be using Cisco, so you're just going to leave that Cisco. But if you ever had to change it, you just go into the router and type in frame-relay space LMI-type space, and then put in whatever type you want. And again, it defaults to Cisco, but you can just do frame-relay space LMI-type space ANSI, and it'll take it. So hopefully, again, in CCNA you won't have to change that, but if you ever had to in the real world, that's how you would do that. Alright, so you've got the serial, the interface is done on the frame relay cloud. And again, obviously the provider would do this stuff, but in Packet Tracer, if you want to make it work, then you go to frame relay, and then you got to kind of associate the links together. So we're going to go to serial 0, which is headquarters 1 to R2. I'm sorry, R1, excuse me. Then we're going to go from R2, R1 to headquarters. So we have headquarters to R1, R1 to headquarters, and let's create that link through the cloud. If we hit add, if everything worked, that link should add. Now at this point we should be good. I should be able to go to here to the headquarters router, and I should be able to ping the other guy, and he was 253, and you can see I can ping. So now I can ping through the frame relay cloud. So in this case, frame relay is all set up, but let me walk you through this one, and I'll show you a little something that's a little bit different on this one. Alright, so I don't want to do that. Alright, so interface, again, he's at serial 000, enter. Now, once I'm in, IP address 192.168.1.250. Don't make fun of me if I talk too much or talk when I type. Alright, set the encapsulation, frame relay, enter, bandwidth, enter. Now, here's something a little bit different. For frame relay, in CCNA we're only talking about Cisco stuff, so we just leave the defaults on there, which is Cisco. But obviously in the real world you may have to commit or have other routers in the process. So same frame relay map command, frame relay map, then the IP address of the destination network 192.168.1.249, and then your local DLCI 301 space broadcast. You can use OSPF. Let me make this bigger so you can kind of see it. Now at this point the default is Cisco and you don't have to type it in. But if you don't have all Cisco stuff, you can type in IETF. And that is a different type that works with, it's an open standard, so if you have non-Cisco stuff, this is what you want the command to do, IETF. Otherwise, we can just leave that off. Alright, again, no shutdown. And the interface should come up. Should be able to go here, grab a connection. He goes to R3, go back up here. Remember, I need to go to 3. His number was 301, and that was R2 to headquarters. Add that. Now I need to make the connection through the cloud. Right now I'm just assigning my entrance points or my exit points. Then I need to go up here to frame relay in the cloud and connect those. So I can go to serial 1 from headquarters to R2, and then go to serial 3, R2 to headquarters. These need to match from entrance to exit, from exit to entrance. If everything's correct and I hit add, it should go in here. If this doesn't work, your frame relay is not set up correctly. Alright, now at this point, again, I should be able to ping. And I can, so I'm good. Now, all we did here in this frame relay was we set frame relay up so that our routers can talk to each other. If I had my remote offices here connected to this, like I had a PC down here that was 10.11.100, and this guy had a PC that was 10.22.100, and this guy had a PC up here that was on 172.16, the PCs would not be able to talk. All we did was make our routers talk through the cloud. So frame relay is just that layer 2 encapsulation to get me through the cloud. At this point, if I wanted to make all my routers talk to each other and share their routing tables and whatnot, I'd have to install a routing protocol. So now I would install EIGRP or OSPF, and then everything would work fine. So at this point, just doing frame relay doesn't mean all your PCs can talk to each other. You still have to install a routing protocol. This is just to get you through the provider's network. It's a WAN encapsulation. So I hope that helps. Alright, so that's the first way you can configure this. Now, there's a second way that's probably more typical that we do. Alright, the next way you can set up frame relay is with multi-point connections. And what I mean is I only have one line coming out of my router into the provider, and then I have other circuits coming in, from the provider. So basically, instead of having one separate card for each connection, or one separate port per card, now I only have one port that's going to go feed all 3 of these connections, if you get the idea. So with multi-connections, again, I just really screwed that up. Alright, let me put it this way. Once you go this route, you have 2 different options. The first option is to do a multi-point connection. And that means this guy here would connect to all 3 of these, but they would all need to be in the same subnet. So that provides problems because of split horizon. If you remember, with split horizon, I don't advertise networks that I've received them on the interface. So in this case, when R1 sent me his routing update to R0, R0 would not pass that update out to R2 and R3. So you've got some issues with multipoint. But again, the two big things in the play there is split horizon has issues, so you'd have to turn off split horizon, and all your stuff has to be on the same subnet. Your next option is a point-to-point with sub-interfaces, and this is typically what we do. So each end is on the same subnet. Let me show you an example. So here's your multipoint. Again, you've got one physical interface, and he's going to have an IP address, and that IP address is going to be in the same subnet as all three of the other ones. So everybody has to be on the same subnet for a multipoint to work. Again, I don't typically see this one too much, but it's there. So again, don't forget, everybody has to be on the same subnet, and you have to turn off or disable split horizon. Now your other option is your point-to-point. So basically, just like with VoIP or VLANs or anything else, you just create sub-interfaces, and then each sub-interface is part of the subnet it belongs to. So sub-interface 1 is 192.168.1, and he connects to 192.168.1, and he's red. And then sub-interface 2 is 192.168.2, and he connects to 192.168.2. So again, if you've got three sub-interfaces, then you have three different networks. So each sub-interface connects to somebody else on his own subnet, if that makes sense. So that's the difference, multipoint and point-to-point. We're going to do the point-to-point because the configuration is a little bit tougher. Alright, it's not really that bad for multi-DLCI setup on the same interface. Again, you're going to go into the interface, you're going to change the encapsulation to frame relay, you're going to bring up the interface with no shutdown, then at that point you're going to go into the sub-interface and select it as a point-to-point, then you're going to assign an IP address, then you're going to assign the bandwidth, and then you're going to assign a DLCI to the sub-interface. So you no longer have to map a destination IP address to a DLCI. You're actually going to map the sub-interface to a DLCI. And that way anything hitting that sub-interface knows it's automatically going to that DLCI, if that helps. Alright, let me walk you through the configuration. Again, it's not that bad. It sounds a lot more complicated than it is. Alright, same starting point as last time, same network, and again, let me put that frame relay cloud in there. Remember, it's WAN emulation, first cloud, just slap it in there. I'm also going to change the name ISP, and then again, boom, so that it's just exactly where we are last time. So I'm going to go into the headquarters, and I'm going to turn it off. I'm going to put in a WIC 1T, turn it back on. Alright, so we're all set. Now, I'll start with headquarters first, and again, all the information's still the same. Go into headquarters, CLI, move this over here, make it a little bigger so we can all see it. Alright, once I'm in, again, same thing, I go to the interface, interface serial 000. Alright, once I'm in the interface, you have to put the encapsulation on the physical interface. So encapsulation, frame relay, enter, and then you have to bring the interface up. No shutdown. Alright, now I'm done with the physical interface. Now I'm going to go into my sub-interfaces. So, interface serial 000. Now, it's up to you how you want to do this. Most people assign the sub-interface numbers to the DLCIs. So it's going to be 102, so I'm going to assign it as 102. So, sub-interface 102. Now, let me show you something. If I try to create this in Packet Tracer and hit enter, notice it doesn't work. You have to put point-to-point after it, and then it'll work. So if you're doing this in Packet Tracer and you can't figure out why your sub-interfaces aren't going, it's because you didn't do point-to-point. Alright, now you want to assign the IP address. After the IP address, the bandwidth, and again I'm just going to slap 64. Don't forget, you would look at your CIRs and then kind of figure out your bandwidth just to make sure your routing statements are correct, and it has the best calculation. Now, here's where it gets different. We're going to do frame relay, but instead of doing a map, we're going to do interface-DLCI. So now we're going to link the interface to the DLCI, and we're going to link it to DLCI 102. So frame-relay space interface-DLCI space 102. Enter. Should be all done. Exit. Now I can go in the other interface. Interface serial 000.103 and put my other stuff on. So IP address. This one's 249. Then bandwidth. Huh. Oh, I must have got out of it. Ooh, what did I do? Misspell interface? Oh, I didn't put my point-to-point on there. Why don't you guys let me do this stuff? All right, interface serial 000.103 point-to-point. See, don't be like me. Don't be that guy. All right, this one's 249. Alright, bandwidth, and then frame relay interface-DLCI, and this one's going to 103. Enter. Alright, he should be good. Now I'm going to go to Office 1. Again, I'm going to move that over here. Alright, no, enter, enable. So interface. Remember, first you have to do 2 commands on the... Don't be like me. First you have to do 2 commands on the physical interface. You have to set the encapsulation and you have to turn it on. So encapsulation, frame relay, enter, and then no shut. Bring that up. Now you can do your virtual interface. I'm sorry, your sub interface. So interface serial, and his DLCI is 201. Oh, don't do what I just did. Oh, okay. Now, again, IP address. This one's 254. Woo! Tell I'm getting sleepy. Alright, and then bandwidth. And then your frame relay. Interface DLCI, and this one's going to go. Remember, your DLCI that you set on your router is always the local one, the one that's been assigned to you. Boom. Exit. Alright, theoretically, this should work. So, got to put my cables in. I'm going to go from serial 1 to the cloud at 0. From him, serial 0 to the cloud at 1. Now, go to the cloud. Again, this part here your provider would do, but if you're doing it in the lab, you'd have to figure it out. So, this one is 102, headquarters to R1, but this one also has a sub-interface that's going to go to R2, so this one gets 2 because we're going to do 2 sub-interfaces on the same physical interface, so he gets his 2. Now, go to 1, his DLCI is 201, and that's R1 to headquarters. Alright, if we did it right, I should go from 0, headquarters to R1, and then go from 1, R1 headquarters. So, enter, exit, exit, enter, and if it works, woohoo! So, we should be set. So, I should be able to go here, and ping 192.168.1.253, and I'm pinging through the cloud. Woohoo! Look at that. Alright, let me see if I can funk this one up for you. Alright, no. Enable. Config T. Interface serial. Remember, from the interface, we need to change the encapsulation to frame relay. And then we need to bring it up. Now, at that point, we can go to the sub interface. And this guy's going to be 301. Now, point to point, just hit P and tab. Oh, you little... It'll be one of those days. I hate when I'm hitting the wrong key. Alright, so now I'm in my sub interface. IP address, and his IP address is 250. After IP address, I'm going to do my bandwidth, and then my frame relay. Frame relay interface DLCI, and his DLCI is 301. And that should be it. Alright, so I'm going to connect him. So then I'll go to my cloud. This guy was 301, and that was R2 to headquarters. Add that. Frame relay. Now I'm going to go from serial 0, but now I'm going to go to the second one, headquarters to R2, then go to serial 2, R2 to headquarters. So in, out, out, in. If it works, bloop. Oh, and it did. Should be all set. So this guy should be able to ping. And ta-da! Works. So again, I can ping. So that's all there is to setting up frame relay, and that's the two differences, whether I have physical interfaces or I'm going to do sub-interfaces. Just remember, all this does is get me through the cloud. If I had put other PCs off of these routers on their native LANs, these PCs at this point would not be able to communicate yet. You have to install a routing protocol. Oh, and I also mentioned we're going to talk about the LMI a little bit. The only thing is, there's another command. If I go into the router and I do from privilege mode, show, and I think it's frame relay LMI. Now you can see all the status messages that pop up. Remember, LMI is link management interface. So I sent this many queries, this many were received. So this is kind of how you can maybe help you troubleshoot some issues, with your frame relay or things like that. But again, it's kind of beyond the scope of the CCNA. They've mentioned this in CCNA, but that's kind of it. But I just wanted to show you that LMI, and this is really what it does. It sends keep alives every 10 seconds or so. Hey, I'm still here for service provider. Hey, service provider, I'm still here. Hey, blah. And then it shows you status messages, and you kind of see and maybe look some of the stuff up to figure out what it is if your frame relay is not working or if you're having some issues. All right, so wrapping it up, remember, frame relay only applies through the provider network. It's just a way for your two routers, the one that's in New York and one that's in Chicago, to kind of virtually think that they're right next to each other with a piece of cable. So it works just kind of like a T1. And frame relay is not a routing protocol. You still need to put a routing protocol on those routers in order to get them to see everything else and communicate with each other. And then last, don't forget that bandwidth command does not change your physical bandwidth. Doesn't set the bandwidth for the port. It's only used in the routing metric. But we want that to be accurate because we want our routes calculated as accurately as possible. Alright folks, that's it for Router Dogs for today. Hope you learned something. If you have any questions about frame relay or anything, check our site, drop us an email, and we'll try to help you out as much as we can. Have a good one.